that I told you that we change this into z-scores. When we change the z-scores, we tell them standardized normal distribution. That means I was changing the kilometers into miles from here going my home, but the rest thing remains the same, and the area under the curve was 1. So normal distribution, we can change into z-scores. That's called the normal distribution. So we have, in the one standard deviation, number of observations was 68% of your data or observation falls here, 95 here, 99.7% falls within the plus minus 3 standard deviations. So this was the score which I was talking about. On one math test, a standard deviation of 7 points. If the mean is 45, then we would know 68% of it. How? You will add the 7.
Yes.
Because it's 1. If it's 2 standard, then 2 into 7. On the plus side and on the minus side. Then you can say why is my observations. So mean is 45. Mean is 45. So add 45, 7. 1 standard deviation. Because we know the 7 is 52, the top end is 52, lower end is 38. Okay. The second. On another test, a standard deviation may be equal to 5 points. Not 7 but 5 points. So you have to add that 5 points to this. So we have a mean 45. So one standard deviation is 5 points. So 45. So we have different values depending upon the standard deviation.
Yes.
Is that clear?
Clear.
So you can calculate anything and everything now. So when I have a right side, that means one of the observations was very big. The mean shifted towards that. Median remained the same. If I was a left side scale, one of the observations small, so mean was brought down.
Median.
Simple.
Simple.
So it was complex last time?
Yes.
No, it was not complex. They are much better than
More than that.
this is right. So the standard, yes.
Value to the right and small value to the left.
So simple. What is the mean? Mean you add the observation divided by number of observations. So if you have numerator is bigger, then it will go to the right. If the numerator is lesser, it will go to the left. No rocket science here. So the normal curve is bell-shaped and has a single peak at the center.
Yes.
The arithmetic mean, median, mode are the same point. Half of the area is here, half of the area is there. That's why I call it symmetrical. Huh? So simple, no?
Yeah.
Nothing to worry about. So total area is equal to 1. So that was part 1 which finished. Now this was something special. We told you that when we talk about a hypothesis, it's a claim about any parameter. Then hypothesis testing means that we test whether that claim is right or not. And we use the real event rule that if the probability is very, very small, if I get a value here, that means the probability of getting that value is very small, then I reject my null. So how did I do? I first created a critical value here. Now I will go and I will show you how. So this I will not repeat. This I will not repeat. This I will not repeat. So the step first was to identify the claim. For example, if the claim is that the prevalence of obesity among adolescents in case is more than 50%, when I say more, it means an alternate hypothesis. And what is the direction of test?
More.
So what will you say?
To right.
Right tail, no?
Yes.
Right tail. You don't remember tails, no?
Yes.
Right tail. So it will be on the right tail. If it is less, it will be on the left side. If it is not equal to, then
Right.
Two tail.
step 2, make assumption opposed to that of claim. You know, in my country, we throw them out of the window. And I don't bother whether any bone remains or not. There in our, not here, there. So you should be there with my own process. So now we are making so it will be equal. I could have written less or more or equal. So it doesn't matter, I will write equal. Is that clear?
Yeah.
Yes.
Then what I will do? Now I will get data on this. So I will take a sample, get a data, and see if I get 50% or if I don't get 50%. Okay. Now I assume that my null hypothesis is true. I collect the evidence to reach one of the conclusion. I will either reject the H, the null, or I fail to reject it. Bottom line is, as I told you, if you have to support a claim, put it in the alternate, then bring the data on the null hypothesis, then move ahead. So second thing is, now we have the null, we have collected the data on null. Now what we do, we need to find the test statistic. So if I have proportions, 30%, 40%, 50%, in this case, it's a proportion, where I'm seeing how many percentage are obese or not obese, then I will use z-test. This is a test which helps me to see whether this is a genuine increase or not a genuine increase. When I say here that I fail, if my value falls here, it is fail to reject.
Yes.
Isn't it?
Yes.
This is rejection. When I fail to reject, I also use the word that the results are not significant. Okay? I also use the word that I have got the results. These may be because of chance. So two more words. Huh? It will not add the confusion, it will remove confusion. It will make it easier. So it's a rejection, not significant region, or a non-chance. Chance region. It's chance, not a non-chance.
Yes.
What about here?
Rejection.
So significant means, non-significant means
Significant.
significant results.
Non-chance.
Non-chance. That means they are not because of chance, they are true results. There is true difference. Okay?
Okay.
My leader once upon a time, you are today also leader?
What?
You are leader this time also? Oh, I thought it was only once upon a time, so you are still leader. So, if I have a proportion, I will use the z-test, and if I have the mean, then I will either report the z-test if I know the population standard deviation. So if my population standard deviation is not known, I will use the t-test. This I will teach you in the next section, inshallah, in future, the tests of significance.
Okay.
So till then, only two things you should remember. If I have proportion z-test, if I have mean, I can use either z or t, based on the population standard deviation is known or not known.
Okay.
So I'll collect the data and calculate the test statistic. Now what I'll do? So, for example, survey has been done on 706 high schools, shows that, we have not done this survey, that 61% of the male students were obese. That means the claim is P is more than 0.5, the opposition is P is less or equal to 5, or it's equal. You got it? Less or equal is same.
yeah.
Test statistic is z-score because it's a proportion which I am calculating.
Yes.
Now I collect the data. I have got the z 5.84. This is my value which I have got. Now what I will do with this value? That's very critical here. Two ways of testing. Traditional or? So I will go for the traditional value. So it is a right tail, left tail, two tail. Now tell me, is it a right tail test? Should I use a right tail? Should I use a left tail? Or should I use both tails?
Right tail.
Why?
No.
Because the alternate hypothesis doesn't do that. So now what's important? Now how much value I have got? I have collected the data, calculated the z-score. If the probability of this is very, very small, there was 95% probability here. Now this probability is very, very small, then what will happen? Then the assumption is probably incorrect. What was my assumption?
Yes.
Because my assumption is this is true, it's equal to 50%. Right? What's there? Is there anything you are looking so seriously? You understand first.
About the climb, doctor, I choose any value, or does it have to be 5?
No, you choose any value. It doesn't mean always you should have 5. You may say 30%. You may say 20%. You may say only 10%.
It's nothing related to...
Nothing to do with it. No, nothing to do with that number. Now this number is very important. What you are getting out of when you correct the sample for this null hypothesis, you got a number. Now you will test it. Now see what will happen.
B value is the same as the test.
Huh?
B value is the same as the test, and traditional is like you mentioned 4 tests now. Z test and proportion for the proportion
And t-test.
and traditional test.
No,
It is the
I
same.
didn't write traditional. I said there are two methods of testing the hypothesis. One is the traditional way, and another is the p value. This was the test statistic which I calculated. I got a sample on this null hypothesis. Then I calculated something which is called as the z-score. Now this z-score I will test it. How? So I have a null hypothesis this, that's correct. Alternate hypothesis this, and a z-score I got this. Now, as I told you, I have to tell how much confident I am. Now I'm telling that I am 95% confident, isn't it? Mostly I used it. So confident plus alpha. Alpha is the error.
Yes.
Error is always equal to 1. So usually alpha is either 0.1, 0.0, 0.1, 0.05 or 0.01. That in other way means that either I am 95% confident, which is mostly used. So the mostly used level of confidence is 5%. And this is called a level of significance. Alpha is called a level of significance. At which level I will say my results are significant or not. So I may be 95% confident, which is mostly used. So if I am telling you, put something about the confidence level, so I am talking about 95%. But you can also use, when I am using 95%, the level of significance will be 0.05. If I say 90%, the significance level will be 0.1. If I say 99%, then the significance level will be 0.01. Because 99 plus 0.01 is equal to 100. So alpha plus C is always equal to 1. Is clear?
Yes.
Now I have to calculate what is called as a critical value. Critical value separates the rejection region from the non-rejection region. At an alpha of 0.05, the critical value is 1.64. Now, where from I got this value? So I checked this value in the tables. It is a table of z-scores. When I checked it in the table of z-scores, here I got a figure 1.64 is the critical value. Now, see, so this is all, this critical value, it separates non-rejection region from the
Rejection region.
critical region or the rejection region. So the critical value is 1.65. That means if my value, which is z, is equal to 5.84, does it follow here or does it follow here? Does it follow below this or does it fall above this?
Non-rejection.
Hmm?
No, non-rejection. Non-rejection.
5.85.
More.
Where does it fall?
Reject. Reject region.
No, here.
On the right. More positive.
Man, this is 0, 0.1, 0.2, 0.3, you have reached 1.65. Now 5.8 is less than this or more than this?
More than.
So why it will fall?
On the right.
Reject.
Reject.
Reject region.
In the reject region. Means that your hypothesis, the null hypothesis on which you collected your sample, the data, then you calculate the z-score, then you calculate the critical value, then you try to find out why my score falls, and it falls be in the rejection region. So what you will do? You will reject your null hypothesis because you can't do anything. So you rejected your null hypothesis means you accept the alternate hypothesis. Is that clear? And this is which type of test? Right side or left side?
Right.
Or both? Right. Is that clear? So when you will check at the alpha region, with this value, the critical value is given 1.65. So you put it on the normal distribution, this 1.64, and see where this value falls, whether it falls in this region, which is called non-rejection region, or in the rejection region. If it falls here, you will reject your null. That means this thing is correct. Is that clear?
Fail to reject the other hypothesis.
What we have to do with the other? I am testing what?
I don't say anything because
What we test? Null or alternate?
I test why not always.
So I always test the null.
Yes.
So two things will happen. Either I will reject my null, then I will accept the alternate, or I will fail to reject it. Means, if it would have fallen here, I will be stuck. Because it falls here, means I rejected this null.
Yeah.
This is
You
correct.
said reject my hypothesis, so I thought I need to reject myself, so I.
No. You rejected this hypothesis. In other words, you accepted the alternate. If this value would have fallen here, non-rejection. So you could have done nothing.
So now, Doctor, this is rejection region, yes?
So you have rejected this null,
So I told them you are wrong. I reject.
your own null hypothesis.
So I
You rejected this null hypothesis.
yes.
You got the data on this. And the data which you got is very, very real. The chances to get this value is very, very real. Isn't it? So you will reject this. When you reject this, you are accepting this one. Is that simple? Or difficult?
A bit confusing, Doctor.
That's why I told you again, repeat it. So can you stand up and tell us that what we have done? Get up. Yes, 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 no problem. I am a student like you. Yes, get up. And let's listen. What you understood till now?
So we
Broadly.
start with the normal disturbance.
Only on the hypothesis.
There is two types, null and alternative. The alternative, there is no equal sign. And the null, there is equal sign. First of all, when we need to assume or to start reject or non-reject, we use a null hypothesis always.
Null hypothesis, okay.
Then
So
there's-
we constructed null hypothesis. Then
Then there's two methods, either traditional or p-value. And traditional depends on it's more or less or equal. The first one, I will choose right or left or both case.
so it is determined by the alternate hypothesis.
First
Isn't
one,
it?
yes.
So then what on the null, you went into the market, you sampled out the population, you got the data. Isn't it?
Yes.
This data, you calculated one value as z-score. Now you have got a z-score, you have to test the z-score. What are the chances of getting this z-score? And you will test it. So what you will do, from this z-score, we will try to find out what is our critical region in the normal distribution. When I do this, find out this critical region, it separates my normal distribution into two regions. One region is called non-rejection region, another is called rejection region. Usually the rejection region is the probability of getting the value which you have got in your null. If it falls there, then you will reject your null hypothesis. And when you reject your null hypothesis, the alternate hypothesis is accepted. Okay? Now second situation may occur that this null hypothesis, the value which you have got, it does not follow in that real event rule. It falls in the non-rejection rule. Then you will say nothing.
Will fail to reject.
You will fail to reject. So you will tell nothing about the alternate hypothesis.
Victor, how about the z-score?
Huh?
The books of the z-score. I will get it in each question or no?
No.
Somehow, from where I know it's 1.65.
I will give now. Where
You will tell it in the.
Obviously, if I put a question, I will give you the critical value as well.
Okay.
Okay, that's fine.
Or otherwise, where from? Or I will give you, I will take from the pocket the scoring system, the table, I will give it to you. To everyone. Okay. So you understood now?
Yes.
Where was the problem? Where was the problem now? There is still some problem, isn't it? I know, there is still some problem in the heart.
Inshallah, come to later.
Inshallah. Because there is still some problem in the heart. The problem why you are not understanding, why there is a little bit of confusion adding. Confusion is adding when I say a non-rejection region, when I say a rejection region, when I use the word a real event rule, you are getting a little bit bored. Let's be frank.
Yes,
Isn't it?
yes.
We also get bored. That's a fair thing. But once you understand it, it's very, very easy. You will love to do it again and again and again. Talk to other people. You will love to explain to other people. Once you understand. Now I said that once I calculated this data, I applied the test of significance on my null hypothesis. And in this case, I calculated the test statistic, which was z. So once I calculated the z, I got a score of 5.84. On this basis, I tried to make a normal distribution curve.
Okay.
So I brought it, placed it there. Then I said, this value, is it usual or unusual? So how will I say whether it's usual or unusual? For that thing, I needed a critical value.
Yes.
So I went to the book and tried to find out what is the critical value of z-score at a significance level of 0.05. So once I checked that table, it gave me 1.64. So once I got this 1.64, I placed it on the normal distribution. then it separated my normal distribution into two regions, rejection and non-rejection. This is called rejection, non-rejection region. This is called the chance region, non-significant region, and chance region. This is called rejection region, significant,
Non-chance.
non-chance. That means these results are not usual, these are unusual results. Okay? So if the chances of getting this value is very, very less, is this less or this less? There is a huge curve.
Yeah.
So this is less under normal distribution, isn't it?
Yes.
So the chance of getting this value is very, very less.
Yes.
So that's why you rejected it.
Okay.
Because 95 you are confident that you will get a value within this, but you didn't got it. The chance of getting this value is only 0.05%. Because this value falls beyond this 1.65, that's why you rejected the null hypothesis. Let's go to another thing. Maybe there is something more in this. So I told you left side, right side, and
Yes.
left side, right side, both sides. You can go it and read it. I have given it long before. Now another thing is that instead of calculating this critical value, getting the z-scores and other things, what you will do, you put the value directly on the normal distribution. Put the value directly. And I told you that the total area under this normal curve is
1.
equal 1. Isn't it 1?
Yes.
So then I will see, I have the significance level of 0.05. I have the significance level that my results will be significant at the level of 0.05, isn't it? Now I will calculate whatever value I am getting, I will put directly in the normal distribution and see whether this value which I am getting, this is called as the p-value.
Yes.
Whether this p-value is more than alpha or less than alpha.
Okay.
Now, in the second situation, what I am doing, instead of finding out these critical values and other things, what I am doing, instead I will be directly putting my p-value here. What is alpha? You see what is alpha here? Do you have any idea about the alpha?
No.
This is a normal distribution. Do you have any idea about the alpha? Anyone who knows the alpha here?
No.
Why don't you know? Because you told me 2 standard deviation here is 95%.
0.5.
5% beyond the
0.5.
You know it. Why are you saying I don't know? So you know it. So because it's on the 2 halves, it will be 0.025 here, 0.025 here. This is your alpha. So you know your alpha, you know your confidence interval.
Yes.
Or if it is only a left side, then 5% will be, if it's right side, 5% will be here.
Okay.
If it's a left side,
5 in the.
5 will be on this side.
Yes.
Okay. So 95% will be here. So this will be your alpha. This is alpha. This is alpha. This is alpha.
Okay.
This is just confidence interval. Got my point?
Yes.
So now we have to see whether, when I put the p-value here, we have to see whether this p-value, whatever it is, your alpha is 0.05, isn't it?
Okay.
We have stated it in the beginning
Yes.
of all your research proposal. My level of significance will be 5%, means 0.05.
Yes.
I will test those results at this level. So if you are directly, here you are doing a traditional method.
Yes.
Here you will directly, what you are calculating is a p-value. What you are calculating?
B-value.
P-value. If this p-value, whatever you got, if it is less than alpha, if it is less than alpha, okay, or you may get a p-value which is more than alpha. Is that correct? If you get a p-value which is less than alpha, it means that you reject. P-value which you are getting is very, very less even from the alpha.
Yes.
So you will reject it. So that means the results are significant. Non-chance. Here, there are more p-values more than that. That means that it's not a real event, it's a frequent event. It falls here. In the traditional way, it falls here.
Yes.
So you say it's a non-chance, it's non-significant.
No chance.
Non-chance.
To be chance.
Here we say it's, oh,
chance.
here we say chance. and non-significant. Here we say significant but non-chance. So, in the studies, what you are getting, they always say you p-value is less than 0.05. In the studies which you have read. So this means that that you have rejected the null and the results are significant. They are not because of chance, they are non-chance. Is that correct? A little bit, it needs a little bit of pulling of your brain, stretching of your. Well, I can't help that. You have to do it. So you, instead of here getting a critical value, you directly put your z value here. So we know. So now z, if you go to the p-value methods, you will look at the table, you will get a value of 1.18. Okay? But you know what is the area under the curve? How much is the area under the curve? 1. So, but we have z this one. So we will subtract area associated with z is equal to 1.18 because we have got it.
Okay.
Here, if you check the tables, you will get that this area is equal to 0.8810. So this is your p-value. We know the value is 1. From this z, it calculated out to be 0.8810. So you separated this. It came equal to 0.1190. Is that clear? So this is your p-value. Now, this is another example. This is not the same example. This is another example. Now, is this p-value less than alpha or more than alpha? What's your alpha? 0.05. Is it more or less than 0.05? So you write here. I'll show you simple. So you write p dash alpha. Alpha is 0.05. Now, what's the p? 0.1190. Is it more or less?
More.
No, this becomes with
No, I'm saying p. This is p.
P is
This
more than-
is p more or less.
B is more than B.
P value is here. Alpha value is here. P is b more than or less?
More.
So if it is more, that means non-significant. That means because of chance. That means failed reject. That means the results which you are getting are not significant. They are not true results. There is an element of chance to get these results. So you have to fill in the gap. So this was basically which we got from the calculation, that is 0.8810. Then we subtracted it from that. This was the actual value which we got. This is area associated with this value. And this is 0.119 is the area. So 0.05 is less than this. 0.05, that's alpha is less than this. Or in other words, p is more than 0.05. So you rejected this hypothesis. You failed to reject, sorry. Yeah? You failed. Because it's small. So is that clear? Here is some element, huh? Because unless you will not stretch your brains and use it properly, that follow the sequence of events, it becomes a little difficult. Now we'll go to the third. What is this conference interval? What is this conference? Now let's quickly move to this. It's very, very easy now for me. So you saw that how this normal distribution is important?
Yes.
If you understand that normal distribution, you are able to go far as hypothesis testing as well. Now, what's this confidence interval? Now, what's important is that if you have the students in Sakata, all the primary school students, and you want to see how many of them have obesity, for example, the 5th class, 5th standard student. So you got a sample from in the kingdom. I'm talking about the kingdom first. So kingdom, all the students in the 5th year will be your population. If I'm only focusing on the kingdom,
Okay.
then if I only focus, okay, that's not my population. My population is only within the Al-Jawf region. So I will take all the population in the Al-Jawf region. That is my population. So if I calculate in all of them, then what I am calculating? The mean, isn't it? Mean or the proportion. Here I am calculating the proportion because I am seeing the percentage of these primary school kids who are obese. That's my population. But I'm not able to carry all this population. I'm taking a sample out of this,
Yes.
isn't it? And with this sample, I got a proportion, because this is a sample, this is a small p or p cap. This proportion, for example, is equal to 0.3 or 30%.
Okay.
So what I am telling, this is an estimate which I have got from the study.
Yes.
So from the study, I got this estimate that in the sample, the prevalence is 30%. Prevalence of obesity is 30% from the sample.
Okay.
It's not from the population. But if it is from true representation of the population, if my sampling is like that, it is a true representative sample of the population, then this estimate should be somewhat, I don't know the population. I don't know what is in the population.
Yes.
But from here, this gives me an estimate. This is an P, this gives an estimate of the capital P. Actual proportion in the
Yes.
population, which I do not know.
Yes.
So this is unknown.
Mm-hmm.
The population
And
parameter is unknown.
Yes.
So I have only the sample statistics.
Which represents.
And I may say, okay, if I got 30%, fine. If any other friend of yours started again this study and he came up with 27% in the same population, what should we do? So these sample proportions, there is uncertainty with this. There is uncertainty with this because you have not taken every number, you have taken only a sample now.
Yes. Yes.
So how you say that it will be happening in the,
Yes.
it will be happening, that same type of proportion, prevalence of obesity will be in the population. So it's very difficult to give the one number. It's very difficult to give the one number.
Okay.
This is the summary estimate of your sample. This is called summary estimate. The X bar is the summary estimate of your sample. From this sample you are talking about the population.
What I mean.
Isn't it? Now, there is uncertainty which revolves around these summaries, statistics of whether it's a qualitative data or quantitative data which you are measuring. So there is always uncertainty with this. So to overcome this uncertainty, rather than giving only one value, I will give a range of values. I will give from 25, 30 to 35. Instead of giving one single number, I will give a range.
Okay.
Why I am giving this range? I am